Okay, so we actually just saw this example and we justified each step that we were doing. And I can just come up above and show you again. So what laws we were using while we were doing this. Well, there's a much easier way to find this limit. Basically, it's just direct substitution. And that's always the first thing that you want to do when you're looking at limits as x is approaching some number. And so looking at this, if we did direct substitution, all I'm going to do is wherever I see an x, I'm going to go replace it with what we're going towards, which is -2 in this limit. So I have 3. I'm going to put a parentheses wherever I see an x, and then I'll go back and I'll replace it with -2. So I have 3 all times -2 quantity squared minus 2 times -2 minus 3. So if we simplify this, we get 3 all times -2 squared is 4 plus 4 minus 3. Again, order of operations. So 12 plus 4 minus 3, we get back the 13, which we got here. So direct substitution definitely is much faster, and that's the way you can do it unless it asks you in that example to justify each step. But since we had done the one above and it was the same exact problem, that was a good way to just show you this new rule. So direct substitution. So if we have a polynomial, and what we were working with before was a polynomial, then what we can do, or a rational function, and we're looking at the limit as x is approaching a, and a is in our domain of f, then we can just say the limit as x approaches a of f of x is just f of a. Go in, plug in that x value wherever we see an x, and simplify. Okay, so that's all nice and dandy, except usually it's not that easy, and you're going to get problems that just don't fall out like that. And especially when it comes to the exam, of course, I'm going to give you ones that you have to manipulate more. It might be one that it's just direct substitution. You should always try that first. And we saw some of this yesterday when we were doing numerical, when we were looking at the limits and looking at the left and right and plugging in numbers that were close to that a. Okay, so note, if you're applying the substitution property and we get anything that is in this following form, then it's called an indeterminate. And so if you get anything where you have 0 over 0, that's an indeterminate form. That limit didn't tell us anything. The other one is an infinity over infinity, and we'll work with limits going to infinity a little bit, a couple days from now probably. So this doesn't tell us anything about the limit. So a lot of times I'll get students saying the limit doesn't exist. Well, we don't know that. You haven't shown it. You just got an indeterminate form and you got to go back and you got to manipulate it. So there's certain things that you can do to help you figure out what the limit is if it exists and you had gotten an indeterminate form. Factoring. So if you have a rational function, you're probably getting some factor that is the same in the numerator and denominator. So if you factor, you can cancel out those factors and then go in and do that direct substitution. So factoring and simplifying and then take the limit, that's one thing to try. Maybe it doesn't factor. So if you look at it and you have radicals in your quotient, so you have a fraction you're taking the limit of, and there's radicals in there, then you want to try to get rid of the radicals. And remember, we can rationalize, and a lot of times in college algebra, we just really concentrated on rationalizing, getting those radicals out of the denominator. But in this class, it's helpful sometimes to rationalize the numerator too. So rationalizing either the numerator or denominator, depending on where your radical's lying, and then take the limit. Okay. So doing one of these sometimes, or hopefully, is going to get rid of that indeterminate form. A little later in the class, we'll look at a really cool rule 2 that will help us um, get rid of indeterminate forms too. Okay, so let's maybe do a quick review of rationalizing denominators before we jump into some examples.